Laws of logic. These are things that you do automatically. It's not new. We're just attaching new names like detachment to it. Look at what we have. We have a premise, and a conclusion. This bar is almost like an addition bar or a multiplication bar, where you have your problem up above and then your answer down below. When you have a premise bar, conclusion setup, we're assuming that anything above the bar is given to you and is true. So let's put given. We don't have to think about it, we know it's already true. You also have to think about this situation as an alternate universe. Don't think about the real world, think about this as a universe where if I play baseball, I always need a bat. And then I play baseball. So within this little universe, no matter what's going on, even if it doesn't make sense in the real world, you take this to be literally true. Does it make sense that if I play baseball and I always need a bat, and then I play baseball, that I need a bat? Is that pretty obvious? Are those the same?
Yes.
I play baseball, I play baseball. What part of the conditional statement is that? What do we call the beginning part?
Hypothesis.
Hypothesis. So what I really have here is a conditional followed by the hypothesis of the conditional followed by the conclusion of the conditional. So whatever shows up over here, I just bring down to here. This is something that's fairly obvious. We just happen to be giving it a new name that you might not have seen before. Symbolically, looks like this. Here's our conditional, here's our premise, and notice, is the second premise the same as the hypothesis of the original conditional? Yes. Once again, we have our conditional, we have the hypothesis of the conditional, and we're saying, therefore, the conclusion is also true. So let's put another true right up there. Whatever you write underneath is supposed to be true. Yes?
Will it always be the hypothesis argument that I can't?
Don't think of it as canceling out, and no, it won't always look like this. If it doesn't look like this or the other laws, then we're going to say that it's invalid.
Does the bottom have to be true?
Yes, once you write something underneath and you followed correct laws of logic, then the bottom should also be true, like we put right here. Let's take a look at our example. This one is actually giving us two variables, R and M. I recommend converting everything into symbols. Makes it a lot easier, especially if you have a large list of premises. I don't know if it's premises or is it premises. How would you do that?
Premises.
Premises? Premises.
Wouldn't it still be premises?
Well, premises would be an I usually.
If I see those keywords,
It's a condition.
conditional, so I'll put this. They're telling me that R represents raining. How about I don't have to mow the lawn?
Inverse.
Let's say negation M. Inverse is used for an entire statement, or one clause will say negation of M. It is raining. So we're writing R again. There's your premise bar. And we will put, therefore, are these two the same? Well, that's the detachment pattern. So what should go down below?
Negated.
It doesn't matter what is over here in the second half of the conditional. It could be a gigantic compound statement. Whatever's there, that is a conclusion. Yes.
What are those three dots?
What are the three dots?
Means they're
Therefore. Next page. We already do contrapositive. What steps do you take to find the contrapositives of a condition?
Switch and negate.
You switch and negates. That still holds true. Switch and negates. This is how it looks with our premise bar, conclusion pattern. And for this example, since P implies Q is on the top, we're supposed to assume that that is true. We're being given a true statement. And now, once we have our three dots, which mean therefore, we're saying that the bottom must also be true. Switch and negates. Now we have negation Q implies negation P. Sometimes it's shown this way. Let's put P implies Q. And then we'll have negation Q. What do you think would be the result then?
P.
Negation P. Sometimes it's split up that way. Means the same thing. This saying the same thing as that because we're saying that this is true, this is true, and now this is true. They've just broken up our conditional into two pieces. Well, you know what contrapositive means, and that's what's happening here. We're changing the Q to negation Q. We're changing the P to negation P. The only difference over here is that we're saying we have P implies Q, and then we're putting this up here instead of including it down here. That's the only difference. Yes?
Is there a way to write that out in like full words, like how P would represent few words of a sentence?
Sure, and you'll see that in your workbook assignment.
Oh,
All we're looking at here are contrapositives in cases where we start with a negation. If I start with a negation here, does it make sense that when I switch it and negate it, that it's gone now? I'm thinking opposite meaning. So when I look at negation E, and I move it and negate it, it's no longer have a negation. I no longer have a negation for F. Now it's just F implies E. Let's see. If Oswald gets 100 on the quiz, and Nestor gets the same score as Oswald, and Rachel gets the same score as Nestor, what's Rachel's score? 100. You just did syllogism.
Yeah.
So you already think in a certain pattern. We're just calling it syllogism. What I just did over there was this. If A equals B and B equals C, then what results?
A equals C.
A equals C. Those are equal signs. When we use equal signs or congruent symbols, we call it the transitive property. And we will be using that property when we get to our proof section of our units. This isn't an equal sign. This isn't a congruent symbol. What kind of symbols do we have in between P and Q and Q and R? Arrows, which stand for conditionals. When we are talking about the same idea with conditionals, we call it syllogism or we call it the chain rule. The chain rule is because we're looking at a link. There's got to be something that connects the conclusion of one conditional to the hypothesis of another condition. When I did my analogy over here with the first row, who was the link? Nestor. Here, the link is B. Within this premise-conclusion setup.
Q's the
And in this case, Q is flowers blossom. This is another good example of why this is an alternate universe. In this universe, when it's spring, flowers always blossom. Do flowers always blossom in the spring at the North Pole? No, there's places in the real world where this doesn't happen. But in this universe, you have to assume that what you're being told is true all of the time. And if flowers blossom in this universe, I always get allergies. Our link was the Q. Down here, we have a link here. Do you have to have only two conditionals? Could you have more conditionals linking each other together? Yeah. So, say that again?
Did you have more than one?
Yes, and you'll see that in your workbook work. Those are the notes. Just practice. Can you see what I mean by you already know this? You do this automatically in your head. We're just giving technical names to what we're thinking about. Try these problems. And there's work on both sides.